Hello and welcome to the section 7.3 lecture today. Today we're going to be still talking about slope between 2 points. Kind of an extension of that idea, and we were introduced to this with the last couple problems of the day yesterday that we did in class. We're going to talk today about finding using slope to find missing points. Okay. So let's take a look at what we have here. Same graphic. I'm not trying to show you anything new today. We're just going to be using slope. So today we're going to be using the slope and some coordinates to find some missing coordinates. And we're going to start here by finding the missing y coordinate. So one thing that you could do is you could have a graph, and you could graph the point that you know. So here I know -7, -6. Right, I could plot that point on there, and then if I use the slope of 3, I can move up 3/1 and put another point. But I'm trying to figure out the y coordinate when x is -2. That's what this means right here, is find the y coordinate when x is equal to -2. And I could just draw a line and figure out about where those are going to be, but that's tough with a slope of 3. And to make sure that my lines are good and straight, so a different thing that I could do that could help me out a little bit is just to keep working out my slope. Keep stepping out my slope, as I usually say. I'm just going to keep going up 3/1 until I hit this line. Okay, up 3/1, up 3/1. And it looks like I get 9. Okay, my initial thought is that this is a 9. And that should be a pretty solid thought, as long as I can count up 3/1 every time, then I should be good. But what I can also do is use my slope formula. So I'm thinking that this is 9. Okay, I'm going to put that right there. But maybe I want to check that more algebraically and check that with the equation more so than with this graph, because this method would work if I had a great printed graph and I knew that I could count my way there. But sometimes that's not going to be the case. If I have some ugly numbers, that's not going to be the case. So let's find an algebraic way to do it. Let's say here that we're going to have that's not going to work too well. In order to do this, I'm going to put the thing that I'm looking for in the 2 position. So I'm looking for a y. I'm going to put that missing y in the y2 position. So this is going to be x2, y2, and x1, y1. If you did it the normal way, went x1, y1, x2, y2, it would still work, but there's an added step in there that I want to try to avoid. Okay, and then what's important here is that my slope is m. So if I'm thinking about the slope formula, y2 minus y1 over x2 minus x1, now I can plug my values in where they go. I'm going to put it down here and solve the equation for the missing value. So my slope is 3, y2 is y, I put that there on purpose, and y1 is -6. x2, I have both of these values. x2 is -2, x1 is -7. I'm going to go ahead and simplify this right side just really quick. This turns into add a positive, so I'm going to have y plus 6. And over here is also add a positive, and that's going to turn into 5, -2 plus 7. So I have y plus 6 over 5 is equal to 3. And maybe I want to put that 3 over here so I can actually work with it. Now I'm just solving an equation. Okay, to solve this equation, I'd multiply both sides by 5. Getting rid of my denominator, and I'll have y plus 6 is equal to 15. when I subtract 6 from both sides, I should see that I get y equals 9, which is what I wanted. That's what I thought. And everything all worked out. So we would say here that y equals 9, and that's our answer. In the next one, we can graph the point that we know at 3, 1. And then I'm trying to figure out what y is when x is 1. And I know with a slope of 2, it goes up 2 and over 1. Right? And I could step this slope out forever, but I'm never going to get back to when x is equal to negative 1. Again, I'm trying to find the y value when x is all the way back here. So I actually have to step my slope backwards. Instead of going up 2 and over 1, I'm going to go down 2 and left 1. I'd rather not have that mark there. Down 2, left 1, down 2, left 1. I'm thinking that the missing y coordinate is negative 3. Okay, that's what it looks like on my graph. Let's verify that with the equation. Again, I want to take my y and put it in the, take my missing value and put it in the 2 slot. So I have x1, y1, x2, y2. I'll show you in a second what happens if you don't do that, but I'll do that on one of the problems below. So using my slope formula, my slope is 2. Y2 minus y1, so that's going to be y minus 1. x2 minus x1, 1 minus 3. So 2 is going to equal y minus 1 over negative 2. And to solve this equation, we're going to multiply by negative 2 on both sides. Negative 2 times 2 is negative 4, is going to equal y plus 1. Sorry, y minus 1. Not sure how it switched. Mathemagics. To undo subtracting 1, I'll add 1 to both sides. And I'll get negative 3 is equal to y. And there we go. That is the same number that I had. Next one, I don't have a graph on this one, so I should come up with a way to do it all by myself. So we're going to go, again, I want to try to put my y in the 2 spot. So we're going to go x2, y2, and x1, y1. So my slope at 0 is equal to y2 minus y1 over x2 minus x1. If I simplify that, that's going to be y plus 4 on top. And on the bottom, negative 5 minus negative 4, so add a positive, is going to be negative 1. Now there's going to be a little bit going on here because we have a slope of 0. When I multiply both sides by negative 1, 0 minus 1 doesn't change. Those go away. So 0 equals y plus 4. And if I subtract 4 on both sides, I'm going to get negative 4 equals y. Now let's say that I didn't do what I said we should do. And I did not put the y in the 2 spot. I'm just going to move this stuff over a little bit to get it out of the way. And I'm going to do this problem sort of a different way. I'm going to say I just went blindly and I said x1, y1, x2, y2. That's what Gall said to do. Don't think about it, just do it. Not a whole lot's going to change if this is what we do. Not a whole lot is going to change because I'm still going to have my slope is equal to y2 minus y1. Well, in this case, the y1 is the y variable. And then x2 minus x1 is negative 4 minus negative 5. Now, you might argue that less is going to happen in this problem because of the slope being 0, but that actually makes this a really good problem to show this on. So I have 0 is going to equal negative 4 minus y. And then if I do this, simplify the bottom, I get a 1. Well, anything over 1 is just itself. Or you could think about, all right, multiply both sides by 1. Still nothing's going to change. You get 0 equals negative 4 minus y. I'll add 4 to both sides. And those cancel, and I get 4 is equal to negative y. This is the step right here that I'm trying to avoid by always putting the unknown in the 2 spot. Okay, is that now I have this negative y equals a number. Okay, in essence, from here we divide by negative 1 on both sides, or just switch the sign. If negative y is 4, then positive y has to be negative 4. And there we go.
Good morning, folks. For those who haven't checked their email yet, I have asked that TLC leads meet in the library at 8 o'clock. TLC leads in the library at 8 o'clock for a 10 to 15 minute quick meeting. Thank you.
All right, then the last one on this side here, let's go ahead and get that done. So I am going to work to put the unknown in the 2 spot just to avoid that negative y step. So we have x1, y1, x2, y2, and my slope is 1/2, y2 minus y1 over x2 minus x1. Here we have 1/2 is equal to y minus 9 over negative 2. Multiply by negative 2 on both sides. Use a calculator if you have to, but that's going to give me a negative 1. And when I add 9 to both sides, I get 8 equals y. And there we go. On the back side, we're dealing with some, that's weird, we're dealing with some unknown x coordinates, okay? Graphically, if we look at it on the graph first, let's put my point -3, -7 on there. And it has a slope of -8. Well, I can't go down 8 and over 1, but I don't need to because I'm trying to get where the y value now equals 9. So instead of looking at reaching a vertical line, now I'm reaching a horizontal line. Right? So I'm trying to find where the y value is equal to 9. And so since I can't go down 8 and right 1, I'm going to go up 8 and left 1. Up 8 and left 1. I get there, and I go up 8 more, and I get to that line, and I'm feeling like it's going to be -3. Let's double check that using our algebra. So I have a slope of -8. Again, I'm going to try to put the unknown in the 2 spot. And the difference here is that my unknown is going to be on the bottom. 9 minus -7 on top, x minus -3 on the bottom. So that's going to turn into -8 is equal to 9 plus 7, which is 16, over x plus 3. Now, really, if you wanted to think of it this way, this is like our proportions work, right? You're solving a proportion here. And if you want to use cross multiplication, you can. I think that's a pretty good strategy and kind of the best strategy that we have. But I do want to think of that -8 as -8 over 1. And if I cross multiply that, I'm going to get negative 8x, plus I am distributing at the same time, so that's actually a minus, minus 24. So if you're unsure of how I got that, that's negative 8 times x plus 3. So I'm doing this cross multiplication here, equals the cross multiplication on the other side, just 16. 1 times 16 is 16. We can add 24 to both sides. And negative 8x is going to equal, thinking too much now. Gosh, yeah, thanks. 40. Divide by negative 8 on both sides. And it looks like we have x is equal to negative 5, which our graph shows the same thing. Shows an x coordinate at negative 5. Next one here, I've got the point that I know is at 7, negative 7. It's down here. And we want to figure out what x is when y is all the way up here at 5. All right, so we're trying to find this one. And it does say that it goes up. Oh man, this isn't going to make it, is it? Up 6 and over 7. So my first point's going to be over here somewhere, and then my next point's going to be even farther, but it'll probably make it. So it is 2 steps of my slope away, but my graph doesn't go that far. This is why we need our algebraic method. When I put a graph on there, I'll never know. That is okay. So let's go ahead and do this how we did on the bottom here. Again, I want to put my unknown at the 2 spot. That's pretty easy. And my slope of 6 over 7 is going to equal y2 minus y1, so 5 minus negative 7. x2 minus x1 will be x minus 7. Simplify what we can. 5 minus negative 7 is 12, and x minus 7 there. We can cross multiply and solve. It's not going to be too pretty. 6 times x plus 7, 6 times x minus 7 is 6x minus 42. And 7 times 12, my brain's not working this morning, is 84. And I'll add 42 to both sides. That looks like, I believe, 126. Oh, it does all work out. Okay. Had my doubts for a second. Oh, I guess that's not. Yeah, that's an easier one, actually. Then when I divide by 6, 120 divided by 6 would be 20, so 126 divided by 6 would be 21. So last 2 here, we'll do them the algebraic way because we don't even have a graph. x2, y2, x1, y1. My slope is negative 4 over 3. y2 minus y1 over x2 minus x1. So negative 4 over 3 is going to be equal to 1 minus 5 is negative 4, and that'll be x plus 7 on the bottom. Here's a way to make this one a little bit easier. I have the same number on top, so the bottom has to be the same number. That means 3 has to equal x plus 7. You would get the same thing if you cross multiplied, but make it easier where you can. If you've got the same number on top and 2 fractions are equal, the 2 bottoms have to be equal. We'll subtract 7. And when we do that, we're going to get negative 4. So x has to be negative 4 in order to make x plus 7 equal 3. A lot of negative 4's in that problem. All right, last one. Let's go x2, y2, x1, y1, and a slope of 1/5. y2 minus y1 over x2 minus x1. Let's do some simplifying here. We have a slope of 1/5. Negative 7 minus negative 8 is negative 7 plus 8, which is 1. And we have the same kind of thing happening here, x plus 4. But also, I have the same issue that the tops are equal, so the bottoms have to be equal. Let me show that just by cross-multiplying this one, even though cross-multiplying isn't going to do anything. 1 times x plus 4 is x plus 4. 5 times 1 is 5. So we'd get the same thing. Subtract 4 on both sides. Those go away. And we get x is equal to 1. And that'll be it. Make sure you write down any questions you have over on the left and ask them on the assignment that has this video. Again, this term videos are assignments, so we should be getting used to that by now. Got to put some kind of a question in there, and I'll do my best to answer it. Otherwise, I hope you have a great day, and we will see you in class.